Hey everybody, Dave here. Today I'm going to be making a Sudoku solver in Power Automate Desktop. This is hilarious to me. And I understand that RPA tools like this, they were made for helping businesses to do productivity things, to benefit the world and to, I don't know, help business processes go faster and make things more efficient. But frankly, I think the best use of Power Automate Desktop is just the most frivolous ways possible. And so that's what I'm going to do today. We're going to be building a Sudoku solver, and I was inspired to do this by I almost said his name wrong. Barish Karakash. Did I say your name right? Let me know. So he did Minesweeper in Blue Prism a while back, like years ago, and I did it in Power Automate Desktop. And now he's done Sudoku. Granted, this was, I think, a few years ago when he did it in Sudoku, but he messaged me a couple weeks ago and suggested that I do the same thing. So I'm going to in Power Automate Desktop. I'm going to go ahead and let the solution play next to me so you can see it solve. It usually takes like 20 to 30 seconds or something. I'm not going to show you the painstaking efforts that I went through to make this. I mean, understand, it would not be interesting. Maybe some parts of it you would find funny, but I think it took me something like, I don't know, 5 hours, 4 or 5 hours at least for me to make this. And I ran into problems. I had bugs. The way that I made the code was extremely hard to debug. It was a lot of fun, but it was kind of painful. I eventually got it to work, but it was really slow, so I refactored it. Anyways, eventually I got to the point where it is now, and it's a good bit faster. I think it still could be improved, but at this point, with the easy versions of Sudoku being at around 30 seconds or so, I'm okay with that speed. And then I think medium is sometimes like 5 minutes or something like that. Maybe it's not that fast, but honestly, the fact that it can solve any Sudoku, I'm pretty happy with. So if you're interested in seeing how I made that, let's take a look at it. So let's start by looking at the Sudoku game or puzzle and making sure that we know what we're going for. I don't want to leave you in the dark if you're not aware of how Sudoku works. I did briefly mention it and kind of show it during the introduction, but this is a Sudoku puzzle and it is rows, columns, and boxes. Okay, and so you have to put in 1 through 9, the numbers 1 through 9, into these different squares and fill them all up. But the rule is that no box, no row, and no column can contain a single number more than once. So as an example, now I'm not actually going to solve this correctly, but let's just say I did something like this, 3, 6, 8, 9. Now, if you look at just this column, this is a valid column because none of these numbers are in here twice. But it violates the rule of that none of the rows can have 2 of the same numbers. So this 1 and this 1, this makes it invalid. And then the same thing with the boxes here. This 3 and this 3, this isn't allowed. So you just kind of have to figure it out. And as an example, I can probably see that on this row, we got 1 and 2 left to enter into here. So let me get rid of these numbers. And I can make the assumption that what goes in this box is a 2, because there's a 1 here, so I can't have 2 1s in this column. Okay, I'm going to put a 2 here, and then the only thing left in this row is a 1. So I'm going to put a 1 here. And so I've solved that row. I would do the same thing for all the rest of the squares, and that's how I'd solve it as a person. But we are going to do it differently for the automation. We are going to use what's called the backtracking method. And this is something that it just made sense to me, but I think at some point years ago, I probably looked this up and so I don't think it's my own original idea or anything, but then I looked it up again recently and it's called the backtracking method. It's the idea that we are going to start with a top left square and we're going to just go really fast, filling in a number and then going like, okay, is that valid? Oh, that's not valid. Okay, let's go to 2. Oh, let's go to 3. Let's go to 4. Let's go to 5. Let's go to 6. And then 6 not valid. 9. Okay, then we go to this one. 1, nope, 2, 3, 4. Is that valid? Okay, so far it looks valid. And then let's go to this one. Let's go 1, nope, 2, 2 looks like it's valid. And then we keep going like that. If we come across a point where, let's say we get up to 9, let's say we get up to 9 here, okay? And then we're like, oh man, none of the numbers 1 through 9 are valid in this spot based upon what we've put in so far. Well, we're gonna get rid of what we had here. So we had a 9. We're gonna get rid of that. We're gonna go back, and this 4 is now gonna go to 5. And then we're gonna go back here and try 1, and 2, and 3. And we're just going to do that for the entire thing all the way down to the bottom. That's really hard for a person to do, but for an automation, that's easy. So I'm going to try to build this piece by piece and try to explain it as I go. The first thing I want to do is on the main flow, I'm going to create 2 subflows so that when we're looking at the main flow, it's very easy to read and it's not confusing. A lot of times I'll build things on the main flow first, and then I'll cut it and paste it into a subflow. So when I initially built this and figured out how this would all work, this main flow looked terrible, okay? And then I cut pieces out of it and created subflows out of it. So let's go create 2 subflows. I'm gonna call this get Sudoku data for the first one, and then create another one, and we'll call this solve by backtracking. And then on the main flow, we're going to call those subflows. So in the flow control group, I'm going to go grab run subflow. I'm going to choose get Sudoku data as my first one. Then I'll grab another run subflow. We'll choose solve by backtracking. So the idea here is what I want to do is I want to go get the data off the page. I want to hold it in memory in a data table. It's just, I've chosen to use a data table. You don't necessarily have to do it that way. But I'm going to hold this in a data table and pass that information to the solve by backtracking subflow. And it's going to go in and figure out what the right answers are and start putting numbers in here. I will mention that there are 2 ways that we could go about handling this solve by backtracking. We could just make this figure out the right answers, right? Just goes into the data table inside of memory and figures out the rest of the squares. And then it could pass that data table to something else. It could be another desktop flow. It could be another subflow. And the goal is for that other one to go fill in all of the data. And I actually built both those methods before. You know, with an input parameter, I could have it either enter the numbers as it goes along or figure out all the numbers and then enter them all at once. And what I found is that when I did the second way, where it figures them all out and enters them all at once, I didn't know what it was doing the whole time because it would just sit here blank and it's just looping and I don't know what's going on. So I would rather it be a little slower, but I can see what numbers it's entering along the way. So in this version, we are only going to do the filling it out along the way method. Okay. But I just wanted to mention you could make it more efficient, splitting it out so that it doesn't enter into the UI constantly as it's going. All right, so let's go ahead and fill out this get Sudoku data subflow. What we're going to want to do is attach to the running browser. So let's go get a browser automation launch new Chrome. It's not actually going to launch Chrome. So inside the launch mode, we're going to change this to attach to running instance. The attach to Chrome tab by title. So I'm not going to change this. So what I'm going to do is put Sudoku into tab title, because the web page name has the word Sudoku in it. So regardless of anything else that changes, it always has the word Sudoku in it, and I won't have more than one tab open that has the Sudoku in it. Otherwise, this might fail. Okay, timeout, I'm going to leave at 5. The variable produced is browser, and I'm going to need to use that. Okay, the next thing I need to do is read the table out of the web page. So I've tried a few different methods for this, but what definitely works the best is just the way that Power Automate Desktop is intended to be used here. We're going to go use extract data from Webpage, and this is actually pretty slick. I kind of like it. This says, so we're using this browser instance. It's already automatically filled in. Bringing an actual web browser window to the foreground while this dialog is open will activate the live web helper. A synopsis of data to be extracted. No data specified for extraction. This will change once we've clicked into it and chosen. So I'm going to go over here and click. Now it has brought up this instead, extraction preview, and I'm going to highlight the box or the table. I don't know why this is different, but what I found is I have to actually right click. I can't hold control and left click in this screen. So I right click on the table and then I do extract entire HTML table. You can see there are other options, but this one has worked the best from what I've tested. Okay, so this is our data. We have, you can see that it kind of matches, right? So the last column has a 6 right here, and then at the bottom we got an 8. Over here we got a 1, just kind of spot checking to make sure that it looks right. And then we're going to go ahead and click finish. Now this timeout, I'm actually going to change to be 5 seconds because let's change it to 10 seconds. I assume this timeout is referring to wait for the extraction to be completed before the action fails. Yeah, so it should never take more than 10 seconds, and I don't want to wait 60 seconds if for some reason it's going to fail. Store data mode, I'm going to choose variable. You can choose Excel spreadsheet, but in this case, we want to work with this in memory. The variable produced, I'm going to call this original data. And I'll show you later on why I'm calling it original data. I'm going to have multiple copies of the data table, one of them as a reference for what it looked like originally, one that we'll actually manipulate then as well. All right, let's go ahead and test this. And I want to show you what the data looks like. So it's going to launch new Chrome by actually attaching, and it's going to extract the data from the web page. And then let's go look at the data. I'm going to open original data. So the column names don't matter to us because we're going to reference it by index number. So we don't even have to pay attention to this. We can just ignore that. One thing to mention, I guess, is this says value 1, value 2. And I don't want to mislead you here. These columns, when you reference them by index number, it is 0-based index. So we are going to refer to column 1 as 0, column 2 as 1, and then the last column will actually be index 8. Same thing with rows. The first one is row index 0, and the last one is row index 8. That can be a little confusing. So this looks like what we'd expect, right? One thing, though, that I don't think is 100% necessary, but I chose to do it so that I know that there will be a number in every single blank. I wanted to replace these blanks with zeros. Now, to replace those blanks, though, I am going to have to run this test again, and I'll show you how you can do this. So right now, I can't select the value that's in here. And what I want to do is I want to find out what is in this blank right now so that I can copy it and use that value to replace with. There are probably other ways to do this, but I think this is simple enough. I'm going to go grab a wait stage and drag that over here. And I'm just going to put a random value in it. It doesn't matter. I'm going to put a breakpoint on this wait. And the point is just that I want to run this attach and then extract data. And then I want it to pause here. And when you run it like this, and you've paused in the middle of a run, rather than actually letting it complete, it will let you edit the data. So I'll go to this original data, and then you can see it'll actually let me edit this so that I could edit it and keep running in like a, in debug mode. But what I actually want to do is select all of this. I did Control A, doing Control C to copy it. And then I'm going to go over and use this. I'm going to hit stop. So I've still got that value copied to the clipboard. Over in the variables group in data table, I want to use find or replace in data table. We're going to choose our original data table. The search mode is going to be find and replace. This is to look for that value that I'll paste in here. I think I actually I'm going to put it inside of single quotes inside of the percent symbols. So I paste it in there. So it kind of looks like a space, but it's not. It actually has like 1 or 2 different characters. I don't know exactly what is in there, but it doesn't really matter to me. I'm going to replace whatever that value is. Now, I am expecting that the web page will always give me that value for the blanks. And so far it has been reliable, but you may find that maybe it changes over time. And so you'd have to adapt to that. I'm going to leave this regular expression off, match the cases off, entire cell contents. I think you technically could turn that on, but I'm going to leave it off because it'll work regardless. And then what I want to replace the text with is going to be a 0. And then search by everywhere. And then I don't need to produce a variable from this because this is actually going to change the original data table, or at least it's going to change the values in the original data table. I'm going to get rid of this wait because I don't need that anymore. And then let's go ahead and run that test one more time. And now what it's going to do is extract the data, and it will replace all of those blanks with zeros. And we just want to make sure that that's working properly. Okay, so now we've got this feels nice and clean. You see what I'm saying? I didn't have to put zeros in those blanks, but it just feels a lot better like this. It feels like I know I'm dealing with only numbers, and I don't know, it just makes it clean for me to move forward with. Not saying that it's 100% necessary. The last thing I want to do on this subflow is I want to set a variable for us to work with from now on. I'm going to call this data. This is going to be a data table, and it's going to contain the same data as original data did. So once it runs this is going to contain the exact same value in data as original data did, but as we go throughout the rest of the subflows, it's going to change the data table, but then leave original data alone. And let's see, let's take a look at that. So here is data, and here is original data. So they should look exactly the same. The next thing I want to create is a subflow that's actually going to get used in other subflows, but I'm going to create it now because it has to do with the user interface. And what we just did was some user interface stuff. So let's create a subflow. I'm going to call this update cell. I guess I could call it square. So cell and square is the same thing to me. So this just refers to any particular cell or square here. And what we want to do is, given some column index and row index, we want to update the value here to match some other value. This is going to get called in maybe a couple of different places, but we should go ahead and build in the user interface thing now while I'm at it. Add UI element. I'll bring this over here so you can see it. Okay. I'm going to hold Control and left click on a cell. It doesn't matter what. I'll actually pick this one so you can see how it's different. So this says table data cell TD20, and that TD20 is what we're going to use. I'm going to hit done. And this was not like a quick thing. I studied this for, it probably took me like 10 or 15 minutes to decide that this for sure is the best way to go. I'm going to edit this table data cell here, double click on it, and you'll see that all these are unchecked at the top. So I'm going to just pretty much ignore all those because it'll work without using any of that. The selector is TD with an ID of TD20. So that TD is table data, which means the column. So wait, table data. Yeah, that's column. That's actually interesting. Usually that means column, but what's interesting here is that, like, I'll do test and you'll see what it'll select, this one, but I'll just change the number to like 60. Oops. Oh, wait. Where do we want to be? Change this to 60. And then test. You see it'll highlight down here. So what I realized was this is just going 0 to 9 and then 10 to 19 and so forth all the way down. Let me make sure that's actually not 9. It's 0 to 8. And then it starts at 9 here. So if I do table data 9 and I hit test, you'll see it'll select, like now it kind of looks like it was selecting that number 9, but it was selecting the cell. Okay, so we'll add 2 to it and we'll go to table data 11, test it just to make sure we know what's going on. Yep, so it goes here. And what I realized is because of that, it's just a simple math equation to determine, based upon the row index and the column index, what the table data will be. So if I say want to enter data into this square, then that is on row index 0, 1 and column index 0, 1, 2. So it's going to be row index 1, column index 2. And the math equation to do that is simply to say the row times 9, so 1 times 9, which will be 9, and then you add the column index. Since the column index is 2, we add 2 to that and we get 11. And so it's table data 11. And that works, surprisingly, for all of the squares. I don't know why that surprises me, that math works, but it did. It did surprise me. So I was expecting it to be a lot harder than that. Okay, so what I'm going to do now, though, is I want this to be dynamic. So instead of TD11, I'm going to change this to be a variable. And this might give me an error, but this variable will exist at some point. So I'm going to call this cell. And whatever we put into cell is going to get used for this ID. So let's go over to update cell, and we're going to create a set variable action. We will set cell here. And actually, let me just put test here for just a second. It's going to give us an error if I don't have this existing. So let me do a couple of other set variables. And I just want to call these row index. Let's call it 0 and column index. These variables will eventually exist, but I don't want Power Automate to give me errors at the bottom if they don't exist for now. So inside of here, we're going to use those. This is going to be TD and then plus, which I don't think you really have to put a plus here for it to work. So I'll just do this. Row index times 9 plus the column index. All right, so imagine other subflows are going to be working on a certain row index and a certain column index. And then they say, okay, I have a number I want to put into the blank. Well, let me set, because these are all global variables, let me set the row index to 5 and the column index to 4. And then I'll call this subflow, and they will go put the new value that I want into the cell based upon the row index and column index that I've set. Okay, so since I just mentioned new value, the new value is going to come from, I'm going to take it directly from the data collection, the data table that we were working with. And I'm just going to take the value that whatever other page is working on. And I do not like this. I don't really like all this global variable stuff, but I'm just embracing it because it's how it's done in Power Automate Desktop. So what this will do is take the value out of there and it will set it into new value so I can work with it on this page. I don't have to do that. I could just directly reference this throughout the page, but it just makes it more clear to me. Now, the next thing is that I had to figure out, what's the best way to enter data in this page. I tried things like populate. Let's see, where is, I tried web form filling, populate text field on web page, and it kind of would work, but it wasn't showing the numbers correctly. And it said to me that whatever this is doing is not triggering the events on the page to take the values. And that's a common thing. So instead, I'm going to end up using send keys, but I'm going to use a combination of the browser automation and also send keys. So the first thing I'll do is press button on web page. And the UI element I'm going to target is the cell that we just created. Table data cell. I could actually go rename that, but I'll go do that in just a second. So do I want to wait for the page to load? I'm going to say no, because this isn't going to be reloading during the running. Let's rename this cell element. And then after we have pressed well, it's not really a button, right? But after we've clicked on that, let's say, then we want to send a key. So I'm going to do send keys. I want to send the delete key. I had to actually find that earlier. It's in miscellaneous. Well, you can't, I don't think it's going to show on screen. Let me try this again. Delete right here. And so if I click on delete, it gives me the curly braces with the word delete inside of it. So I just remembered that from having done it earlier. So I'm going to send the keys into the foreground window. Is that the best? I think you'll see it works well enough, but this can be risky. You just have to make sure that the right foreground window is there. Otherwise, it's going to send these keys. It's going to send the keys wherever. So I'm going to delay between keystrokes. I don't think this matters. I'm going to put 0, but I have no idea what effect that has on a key like this. Send text as hardware keys. I'm going to leave that off because it's not necessary for delete. And that's because I've tested this. I've tested this all different ways. I'm going to copy this send keys. And right here, I'm going to change this one to send whatever value it was. It was new value right here. So new value. And then this one I am going to turn send text as hardware keys on because that is necessary for it to work in this case. Again, just because I tested it. Now, the other thing that I did find, I'm going to go ahead and do this now, is I want to put an if statement around this send keys for the new value. In the web application, when I type 0, what it does, just because they built it to do this, it doesn't put a 0 in the blank. It doesn't leave it blank. It doesn't clear the value. It doesn't do any of that. It actually like puts all of the possible numbers in there. So if, I guess this is just to make it easier for you as you're learning, you could hit 0 instead of you figuring out that only a 4 can go here. You can press 0 and it'll tell you. I was struggling to figure out what was going on every time it was entering a 0 into a blank, just because things were going wrong, but I didn't understand what else was going wrong. It would try to enter a 0 into the blank and then it would cause all of this. And I was like, what is happening? Is it typing a 3, 4, and 7? But it wasn't. So I'm going to put an if statement. I'm going to say if new value is equal to 0. Actually, we need to say if it's not equal to 0, then we want to do send keys. If it is equal to 0, then we want to bypass and not do anything. Now, This does mean that it is going to select that cell and hit and send delete and stuff. But theoretically, this actually should never happen. But I just like to put this in place because I don't want to see this happen at all, even if something is going wrong. The next subflow we'll deal with is solve by backtracking. In this, we are going to end up calling update cell, and we're also going to create some other subflows as we get to them. Now, when we start this subflow, what we want to do is make sure that our column index and our row index are sort of reset. So I'm going to go over to update cell where I created these, and I'm going to cut them out. You see how I made an error? That's why I put them in there before, because that's just annoying. I'm going to go over to here and paste it in. Now that they exist somewhere else in the flow, this isn't going to give me an error anymore because it recognizes those exist, these variables. I am going to change column index to -1, and I can show you in a little bit why that is. But basically, I want it to start at -1 so that I can, as I start a loop down here, I'll just increment this to 0 the first time, and then it will work after that. But if you have it set at 0, I found it just didn't work. And that's purely because of how I designed this. This subflow is probably going to be the worst design of all the subflows, but I don't think it's that bad. It's probably the worst one. The overall concept that I want on solve by backtracking is I want a variable called isSolved, and then we're just going to loop over and over until isSolved equals true. So we're going to set it to false to begin with, and I'm going to go get a loop that has a condition. We'll say isSolved equal to false. So it's going to iterate this block of actions as long as the specified condition proves to be true. So in this case, we're saying while isSolved is false, we're going to keep trying to solve, and we're going to loop over and over again. We need a subflow that will help us pick a cell to work with. Okay, so I think we're just going to have it start at the top left and work our way right. So we're going to create a subflow. Let's call this find next editable cell. Inside this, we're going to do something very similar to what we just did with the isSolved, and we're going to set a variable here called isEditable. We'll set this initially to false, and then we'll go get a loop condition that watches for, that will loop over and over while editable is still false. So the goal is we're going to do whatever we need to inside this loop to find a cell that is editable. Once we found one that we can call editable, we will say this is true, and it will break out of the loop after that. It will go back up to here, and then it will continue on. Oh, actually, now that I think about it, I need to put a subflow reference here. Flow control, run subflow. We need it right here. Find next editable cell. Okay, so here, it will go down, find an editable cell, come back up, and then we will go in and start looping. This is where I was saying it's necessary to have column index set to -1, because this thing would basically skip the first cell if this wasn't set to -1. So this thing's going to increment column index to 0 and then start going from there. It's not perfect, but it'll work. So back over on find next editable cell, we need to fill in this loop condition. While this is not editable, we need to find one that is. All right, so the concept here is that we need to find a column index and a row index. So let's go get an if statement. We're going to say if column index is less than 8, and if that equals true. So actually, I could put column index is less than 8 like this. Maybe I'll make it a little more readable. If the column index is less than 8, we're trying to find the next editable cell. So this is 8, this column right here. If it's 7 or less, then it's easy to find the next editable cell, or to try to find the next one. All we got to do is increment column index. So let's go get an increase variable. Let's set this to column index. We're going to increment by 1. I'm going to add to this, but just so you can see the simple version of it first, I'm going to jump down and say, now, if the column index was less than 8 and we increment it right here, what are we going to do after that? How do we identify if something is or is not editable? How do we find out like whether this cell or this cell is editable? Well, my idea is using that original data data table that we were maintaining, right? So we have original data that should contain the same data as what we originally found on the board. Then we can look to see which cells equal 0 and which cells do not. And that helps us know which ones are ones that we can type into and do stuff with versus ones we shouldn't. So let's go if original data, and then we want row index, column index, if where we are now is equal to 0, okay, then we can set, actually we can grab this. Then we can set is editable to true. Okay, so once we've done that, once it goes inside this if statement, then it will come back up, and when it evaluates the condition, now editable will be true. So it won't continue the loop anymore, and it will just leave this. That's when it will go back up to solve by backtracking and continue on to where it's supposed to go. But like I was saying, we need to add more to this because there are more situations. So if the column index is less than 8, then it's easy. We just increment the column index because we want to go to the right. But if we're all the way over here, we need to do two things. We need to change the column number from 8 to 0 so that we can jump back up to here. And we need to increment the row number. So we can just copy increase variable. I need to drag an else. We can increment the row index by 1, but we need to set the column index to 0 so that it goes back to the beginning right here. And then now that we've handled column, we can actually just copy all this, paste it. Here I'm going to do the same thing with the row that we did with the columns. So row index, I think we might need to change this logic. Let's see. So if the row index is less than 8, actually this is just going to be row index greater than 8. Where's that? Greater than. So when the row index gets to greater than 8, that would mean that once we've gotten to here, this is 8. But once we get to higher than that, and we're basically outside the game board, at that point, we have already solved all the numbers before, and we can call this solved. So I'm going to click save. I'm actually going to delete these parts. So now it's a little simpler. So we have our column stuff up here, and then we have the row. This is going to not increase anything. This is just going to set is solved to true. And then because we need to break out of this loop, we're going to do an exit subflow. Exit subflow here. Now I could have set is editable to true, and that would have made it leave this this loop, and it would have gone out of the subflow as well, but this works well enough. So we'll jump up to the top up here. That'll send us back to solve by backtracking. And in this case, what we've built it to do, it's never going to come out of this spot having been solved. It's always going to be the other times that we call find next editable cell. This is like the first time just to get us started so that we start from here. And then we go into the loop, and we loop a bunch of times going to different cells. So it's never actually going to finish here though. In solve by backtracking, when we're in this loop for trying to solve the thing, we are going to set a variable. We're going to call this current value. Again, this is something I don't have to set it into current value. I think it does help actually. Yeah, it actually does help for more than just readability. But technically right here, I wouldn't have to do this. Data, and I want to get row index, column index. We're going to get whatever we're working with right now. We're going to put it into current value and then work with current value on other subflows and stuff. Now, what we're going to get out of this the first time, it's going to be 0. And we don't actually want to even try entering 0. So we're always going to increment this current value one time at least. Current value. We're going to increment by 1. And after we've incremented it, and we're saying that right here, instead of a 0, we're going to put a 1. But we should find out, is it valid to put a 1 here? Now, in this case, you can see it's not, because there's a 1 already in this row, and there's a 1 already in this column. So it's not valid. We would want to be able to determine that. And if it's not valid, then go to 2, and then go to 3. So let's create a subflow called validate current value. Again, this is global variables. So when I set current value here and I increment it, this is global. So now when I do a subflow over here on solve by backtracking, and I call validate current value over on this, I really, really wish we had input parameters right here. I feel like that would be not hard. Microsoft they could even keep them all global. That's fine with me. I just want to have input and output parameters with these things, but it's okay. So we go over to validate current value. So we are dealing with 3 global values right here, global variables. I think it's column index, row index, and current value at the very least. So we're going to work with those here. Now on this validate current value subflow, we are going to do something similar to the others where we're going to have sort of a main focus. Our main focus is current value is valid. We'll set that initially to false. And that if we determine that it is valid, we will change that to true. Otherwise, it will stay false. And then the previous or calling flow will actually need to check to see, was it valid or was it not? The first and easiest thing to check for is if the current value is greater than 9. So you can only deal with numbers 1 through 9 in a Sudoku. And based upon how I'm going to loop, I will end up causing it to increment to 10. So when we reach 10, that's when we're saying, okay, well, in a specific cell, so if I get 5 and then 6, 7, 8, 9, I find that none of those are valid in that spot. It means one of these back here are incorrect and I need to change those. I'm going to actually just pretend like I'm going to 10, right? But that's not valid. So I need to delete this and then go back to the previous one. So let's put in a check for if the current value is greater than 9. Then what we're going to do is set yet another global variable. I know it's painful. We're going to set this to go back. Go back means go from this cell to this cell, or from this cell to this cell. We're going to set go back to true. And actually, while I'm at it, I don't know if I did this originally, but just to make it explicit, I'm going to call this go back false, so that we kind of initialize the variable, say that its default is false. We will change it to true if necessary. In these situations where we identify that it is invalid, right? Whatever value we're on and the certain place, so say it's a 5 here, we're trying to put a 5 into this blank. We know that that's invalid. If we ever identify it's invalid, we don't need to go through the rest of the logic. So we're immediately just going to exit the subflow and go back up. So sort of like an early return statement. Here we go. Okay, exit subflow right here. Okay, now this next part might feel a little painful, but I promise you it is more efficient than what I had the first time. Okay, so what we're going to use is an action, and maybe you've never used this before. I don't know if I have or not, but there's an action for data tables called find or replace in data table, which I guess now that I think about it, we used this earlier on, but we're using it a little different this time. Earlier, we were just replacing values. Now we're actually going to use the output. So let's go use data as our input, our data table. Search mode is going to be find, not find and replace. We're going to use find. We do want all the matches. The text that we want to find is going to be our current value. So what we're trying to do is get a list of all of the row and column locations where our value is at. So let me delete this. So if I have like 5, then if I'm looking for 5 and I'm thinking about putting 5 here, then it's going to tell me the row and column number for this, and this. So to give me 3 rows, and in those 3 rows, there will be a row and column number I can use. So I'll show you that in just a second. So regular expression, not going to use that. Don't need to match the case, and matching the entire cell contents is unnecessary in this situation. So not going to turn that on. Maybe, I wonder if it would run faster if I did that. But anyway, search by everywhere. We don't need to search on column, and maybe I'll explain a little bit. The variables produced, we're going to call this just matches, just so it's a shorter name. Okay, so I'm going to go ahead and implement a loop here, and then we're going to come back and add a little bit more to it. So let's do a for each loop. What's it called here? Loops. Oh yeah, it's called for each loop. The value that we're going to iterate over is going to be matches. what I want to call each item, I can call it whatever I want. So I'm going to call it match. This result, just to be clear, this matches as a data table. It's going to give us a result of match in each time we iterate over this, each time we loop over this, it's going to give us a row, and that row is going to have two columns. One is going to say row, and one is going to say column. So that's going to be a little confusing, but I wanted to be clear. This is looping over a data table, giving us rows, and then inside that is it has two columns called row and column. Now let's put an if statement in here. What we're looking for is to validate, this first one's just going to validate whether the row or the column contains our number. So what we've done already is get a list of the locations, right? We got a list of this location, and this location. We're going to look in those results to see, do any of these, are there rows the same row as where we want to type into? In this case, it is. So if we wanted to type into here, then our row is the same number as this one right here. So we would expect this to fail the validation. It'll be not valid. So here's the expression. We're going to type match at a specific column called row. There's a single quote there. I don't know if you can see it well on the screen or not. It might be kind of tiny. So match, and in square brackets, and then single quotes, and then the word row with a capital R. If that equals our, let's see, if that equals, now is this where I want to check for current value? No. I don't want to match this against current value. I think I made that mistake before. We're just trying to see now if the row index we are on matches. If the row index we are on, it matches the row index of the result for where 5 is. Need an extra percent symbol there. So if, oh wait, I could have done this. No, that's right. I want a longer expression. I'm going to do if the row equals the row, and, or, let's see, or match column equals the column index that we're on. If that is true, so either one of these can be true. Either the row is the same or the column is the same. So if either of those are the case, then we want to, if either of those are the same, we want to exit Subflow. And so what we've taken care of is the row. We can check the row and we can check the column. But we haven't dealt with the boxes yet because those are also a validation. If, for example, I'm trying to type a 5 into here, yeah, there's no 5 on this row and there's no 5 on this column, but there is a 5 in this box. So we have to add that validation in just a minute. So let's go ahead and we actually have to we got the row and column numbers for the locations of 5 or whatever the number is, but we need to, so this is going to hurt. This might hurt your brain a little. If it hurt my brain, that's for sure. I stared at the screen. Again, I want to give some like clarity on this. It probably took me like 10 minutes just to maybe 15, I don't know, just to figure out this logic of how do I get the ranges. So let's say that I am going to enter a value into here. So this 5 into here, I'm working on this cell. I have my column index and my row index, but how do I determine what the range is of all these cells here? Well, I went with what looks really terrible, but always works. And we're going to go with a switch statement. So it's basically going to just check, is the column index and row index that I'm at, is it within some certain range? If it is, then here's the range you want to deal with. So let's go build that. I'm going to go create a subflow called get box ranges. So let's go back to validate current value, and we're going to add it in right here. We want a subflow right here. We're going to call get box ranges. And so inside of get box ranges, let's go to there. I'm going to use regions here. Let's go to flow control. I'm going to add in region. Let's call this get column ranges for box. And then I'm going to duplicate this. We'll call this one get row ranges for box. This just helps organize it because this is going to be a code that goes off the page. It's not that complicated, but it's going to be a number of lines. We could do a switch statement or an if statement. I don't think that really matters, actually. So let's go with if column index is less than 3. Now remember that this is 0-based index. So column 1 is 0, column 2 is 1, column 3 is 2. Okay. And so if the column index we're on right now, if that is less than 3, then we'll go into here. We want an else if column index is less than 6, then we'll go into there. And then else if, actually we can just do else. That'll make it simple. Else, okay, inside of here, then we want to do is set our ranges. So I'm going to be using more global variables. Set variable. We want this to be column. So column minimum is going to be, let's see, if it's less than 3, then the column minimum would be 0. And the column maximum is going to be 2. What this is going to tell the rest of our code, somewhere, wherever else, it's going to say that if the index we're on for the column is less than 3, then we definitely, when we're trying to determine whether a certain number already exists in that section, then the column sort of range we want to check is from 0 to 2. So let's copy this and paste it here. Now the column range is going to be 3 to 5. 3, 4, and 5. And then the else is just because if the column index is greater than 6, then we don't really have to care. It's just going to be 6, 7, and 8, which are the last 3 columns. So 0 to 2, 3 to 5, and 6 to 8. Now we're going to duplicate this. Same logic for rows. So let's close this and paste into here. And I'm just going to change the name from column index to row index. Everywhere that I see column, that will get changed to row. And I don't think the values actually change otherwise. Row minimum. We've got row maximum. Row. 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 And after this, I need to make sure nothing is left. Okay, so this needs to be changed too. So we don't want to leave anything as column in here. Copy and pasting will get you sometimes. Okay, so here we have, so on this subflow, get box ranges, what we're getting is the column minimum and column maximum depending on what the column value is, and also the row minimum and row maximum for whatever the row index is. Now we can go back up to validate current value, and we've already called that. So this is going to set global variables of column minimum, column maximum, row minimum, row maximum, and we're going to use it as a second if statement inside of this for each. Now this might look a little awful, but I just wanted to show as an example, you can do, I wouldn't call this a complicated expression, but it certainly has more characters in it that you might normally type in an expression here for readability. But we're going to have percent symbols around the whole thing. And I know that we're going to have multiple sort of checks. And so this whole thing needs to equal true by the end. So if anything in there, or maybe if all of it is true, I don't know how to look at that. So we want to look at is the match. Are we still dealing with match? So yeah, we're in the for each match. So match row, if that equals, what row are we on? Row index. Our row index. No, that's not right. If it is, we've already determined this. Okay, so match row, if it is greater than or equal to our row minimum. and it has to be that same thing, row, match row is less than or equal to row maximum. Then we could put parentheses around this, but I don't think it would actually matter because we want all this to be true. So that whole thing needs to be true. And if the match, I don't need a square bracket before that. It's just match, square bracket, single quote, column, single quote, close square bracket. If the column is greater than or equal to column minimum and match column is less than or equal to column maximum. I'll go ahead and put these parentheses around that just to make it readable. I could probably line return it, but I think that's pretty clear. I don't know. Let's see if I can. Oh, you can't line return that. Okay. Anyway, so that's the expression. And then if that's true, it's the same thing as up here where we're just going to exit the subflow. So any of these where we exit the subflow, that's just saying that the current value is invalid. And beyond that, if this one is invalid, so current value, if it's over 9, that's saying, hey, we got to go back actually. And so we can't even deal with the current cell anymore because something's wrong before this. So that is the validate current value subflow. I almost missed one thing. So if we pass all of these, let me just minimize these. So if this passes and this passes where we don't find any matches. So remember, if we find any matches, that's invalid. But if we don't find any, wait, let's paste this, drag it down. Okay, that's annoying. Drag this out. Okay, what I did was copy this up here and paste it down here, but it was trying to paste it into here because that's just what it does. So I'm going to change current value is valid to true. And that's important. So we know that we can use that number when we go back up to solve by backtracking. So now though, that is validate current value. And we finally finished that. Solve by backtracking, we can continue on that. We're going to create a couple of if statements. In this first one, we're going to check to see if current value is valid. See if that is true. Okay, we're going to do an else if. Remember that go back value, we want to check that. So if go back is true, then we'll do stuff in here. I did find that these need to be mutually exclusive though. So if the current value is valid and we run this stuff inside of here, we then don't want to even check if go back is true. I don't know that that 100% matters, but I did find it to work to just make them mutually exclusive. I think this is a little confusing, and I think if I refactored, this is something I actually this whole section is something I would tackle. What I'm going to add to first is in this go back part. If this go back is true, then we want to go back up here and we want to increment the value again because this is the situation where if we're at 5 and this is invalid, okay, well, we want to increment again and do it 6 and then go to 7. To get that functionality, we need a little bit of a sort of a sub loop in here. I don't like go-to statements, but I'm going to use it here anyways. So where I want it to go to, I think, is right here. And we're going to call it increase current value again. And then we're going to use a go-to inside of this else if using go back equals true. We're going to call increase current value again. However, if the current value is valid, then we actually want to do an update to the page to put the number in. So let's say we get to 7. We want to actually put that number in. So let's grab this and we're actually going to flip it. So we took the value out of the data table. We're going to flip it around and we're going to put that value back. Because now we possibly have changed it. Well, I guess we've guaranteed to have changed it by this point, I think. Yeah, we've guaranteed to have increased it at least one time. So we set it back. And then what we need to do is we want to actually go enter that into the web page. And that's where our update cell Subflow comes into play. So we're going to go get a Subflow, run Subflow here. We've already built that. So we're just going to call update cell. So let me connect it for you. So what's happening here is we are setting our current value that we were working with, we're setting it back into the data table. And then when we go into update cell, here we are dealing directly with that data table. So we're getting the value out. Again, we don't actually have to do that. We could take this data, row index, column index, we could call it directly here. I just decided to call it new value. Matter of fact, is that really necessary? It's a little confusing, but I don't know. I kind of like having a name for it. So it sets new value from there. That way our data table is updated and we're about to enter it into the page so that our data table in memory still matches what the game board looks like. So we're going to go back over to solve by backtracking. We've got this. So remember where we're at is we are in this loop of checking, doing things, and checking to see if it's solved. So we are incrementing our value wherever we are on the page. Once we've actually found a value that's valid, then for that specific cell, then we will update it in the UI. Now let's say that we get to here and the current value is not valid and go back is not true. So we actually passed this area. So I'm going to minimize that stuff. We're going to do another if statement. If, let's see, what did I just mention? It was if go back is set to false at this point. Okay, I actually have to switch this around. I messed up a little bit. So this one is supposed to be if go back is false. And this one is supposed to be go back is true. That makes a lot more sense, actually. So if go back, it's checking to see if the current value is valid. If it's not valid, then we can assume that it is invalid. So technically in this check, we are going, is the current value invalid? That's implied in this because it would have gone in here if it was. So current value is invalid and go back is set to false, meaning that we should increment our value in the same spot. We don't need to move positions. We just need to increment our value. And that's what's telling us to get to here, go up and do that again. Now, do you see how confusing this is? That's okay. Sometimes this just happens. I do think refactoring would be good here. So if go back is set to true, then what we've got to do is whatever logic is necessary to go from here to here to here, whatever is necessary. First thing we're going to do is set a variable in here. We're going to set current value to 0. We're resetting it because if go back is set to true, that means we've reached 10, or I guess we've reached 9 inside of a square. So 8, and then we went to 9. Can't do 9, just can't do 10. So now we've got to set it back to 0, but this might have a value sitting in it, like 5 or whatever. So we need to actually set that back to 0. So we're going to do that by setting current value to 0. Then also in the data table, so let's go copy that from here. We actually need to copy the value, our current value, which is 0, into the data table as well. So we've got our current value back to 0. Our data table now holds that as 0. And now we need to actually update the user interface. So let's go call a Subflow. Run Subflow. Let's call that here. Do update cell. Remember that update cell is just going to use whatever's in the data table in that same spot. It's just going to update that one cell or that one square. Now that we've kind of prepped the one that we're on, we need to actually move backwards. So we'll go to here and then here and then here. So we have a subflow for find next editable cell, and we're actually going to copy this whole thing. So I'm going to right click on the entire subflow, copy it and paste. And then we're going to edit this copy. We're going to call this find previous editable cell. I'm going to have to change a couple of things in here. So assign variable is editable to false, that's good. While is editable false is good. Instead of going column index less than 8, then we actually need to change this to column index greater than 0. If we are dealing with a column index that is greater than 0, it means we still can move backwards. So that means we're somewhere from between here, and we can still move backwards by 1 without going off the game board. However, if that's not true, meaning that we are on 0, then we want to change the column index to 8, and we actually want to decrease the row index. So get rid of the increase. So we want to decrease row index by 1 and assign the column index from it was 0 and now it's going to go to 8, so that we can kind of go from here, go up 1 index for row and go all the way over here for column, so we can continue going backwards. Then of course we have this. If the original, we don't need, let's see, I don't think we need to check the row, because we should never reach the actual beginning to where we would try to go above the game board. I don't think that's possible. And when we're going downward, we do need to check for when we've gotten to the end, because we're checking to see if it's solved. But I'm just going to delete this. So we don't need a check for the row at this point. We still have the same thing here though. Original row index, column index. If the original position had a 0 once we originally got the data, then that means it's an editable field, and we're ignoring what's currently in there, right? So it could be any number in this, but this, we're looking at the original set and going, like, what did it used to be? Okay, that's editable then, and now we can leave. So now our find previous editable cell is done. We can go back over to solve by backtracking. Now we are dealing with when the, we need to add a subflow here. So run subflow, find previous editable cell. And now that we're dealing with when go back is set to true, so we're doing some stuff. Once we go back and find an editable cell, we need to reset that. So let's set a variable. Here, we're going to set go back to false, so that we don't keep going back. Now, I don't know if it would actually matter. I think it's possible that go back gets set to false automatically somewhere, but I just don't want to take that chance, so I'm just reversing the Boolean just in case. Now, if we reach this point and go back is not set to true, so we get past this logic up here and we get to here and go back is not set to true, then that means we can go forward. So we're assuming go back set to false. We're basically saying go forward is true. We just don't have a variable specifically tracking that. So I'm going to go over here and grab an else, and we are going to call this same subflow find next editable cell down here. So this is where it's called within our is solved loop. This all looks good. This is the most complicated page, I think, or the most complicated flow. I don't like it that much. And as I said, I might would refactor it, but I actually already have a good bit. So I've wrapped validate current value and update cell and find previous editable cell and find next editable cell. I've wrapped those in their own sort of functions. And so it's not as bad as it was. So I'll say that. At this point, I think we might be done. So let's save this. And it is time to test it. Okay, let's go ahead, and I don't think we can run this. I'm gonna run this in debug mode so you can see it, but I don't think this is gonna run fast enough. But you'll see that it'll attach. It's extracting the data from the web page. And here, I think we might have, I don't know what was going on there. I've never seen that happen. Okay, let's run our test. Maybe, do we want to run our test again? What is happening? Clear pencil marks. Let's stop this. I wonder if we have something selected wrong. Let's reset. I'm going to run this, and let's just see if maybe we have something. Maybe we had something selected wrong, but I don't know what that would be. So we might have an incorrect selector somewhere. Let's let it get, okay, it is doing something different. We need to figure out what that is. Clear pencil marks. We're going to find, update cell. Let's put a breakpoint here, and we're going to just run it again, and it'll break when we get there again, before it actually types into the UI. So let's see here. So assign to variable cell. Let's step over that. Let's see what's in cell. do this. So we are working with TD4, which should be 0, 1, 2, 3, 4. So that should be this one. That's interesting. Set new value. Let's go find new value and pin it to the top. Oh. Okay. I don't know if you saw the problem. I need to search for current value, not new value. Variables, that's not what I want. I want to search for current value. What I think I did is I have hard-coded the word current value somewhere. Which one is this? Line 11. In here, I actually typed current value hard-coded. Boy, that'll get you. Holy cow. Okay. Current value. It was in at least one other place that looked like. So here you can see these single quotes kind of indicating what I did. Now, where is this? This is saying line 18. Here. Let's put quotation marks. Or not quotation marks. Those are percent symbols. Let's look one more time for current value. And as long as I don't see current value in this list with single quotes around it, then we should be fine. Okay. Let's save that, and then we'll run this test again. I'm only going to let this run a little bit because I think it's just going to run too slow in debug mode. I actually really tried to make this more efficient using built-in actions in Power Automate Desktop to accomplish it. And I just couldn't get it to work reliably, or not reliably enough, efficiently enough inside of debug mode. I think you'll see, like, you can see how many times it's looping and stuff like that. And I've already removed a bunch of the looping that it used to do. Well, now this is broken, so it shouldn't be going to 6. Let's go look at the data that it thinks it has. So let's look at data. Where's D? Data. I'm going to pin that to the top. So it thinks that 5 is inside of this. So it looks to me like it thinks it succeeded in doing that. And I'm actually just going to, for now, just for the testing, put a 5 here and let it continue a little bit and just see how it does. And we might just have some kind of problem that occurred during this test before, which has broken our current test. I just want to see it enter one more. Okay, so it entered 9. I don't really care if that's the right value right now or not. I'm going to hit stop. We're going to refresh this, get a new board, run this again, and let's just make sure it fills in the first one correctly. If it doesn't, then we may just have some kind of index issue. Okay, so it did enter into the first one. So let's go ahead and stop this. I'm going to close. I guess I should save. I think maybe all I changed was the pins. Okay, let's go ahead and run this. Whoops, modified. Can't actually see the full name. Okay, here we go. We're going to run this one. Oh, let's stop it. Should have refreshed it. One thing we did not build in is any kind of handling for, like, what if we put a number in here and that's the wrong number. Now, if we put the right number, that's okay. So if we were solving this ourselves, typing in the numbers and stuff, and we put in the numbers correctly, but only some of them, then we could start this at any time to finish it for us. Now, okay, yeah, so something's not working correctly. I'm going to go ahead and, did it stop? Okay, so I'm going to troubleshoot this a little bit, figure out what's wrong. So we'll just search for column index, and we'll go glance at each of the places where that is. Okay, that's exactly what it was. So on this find next editable cell, this is the copy paste problem. When the column index is less than 8 and we want to move to the right, we should increment it. But when you were doing find previous, we're moving to the left. This was basically just never going backwards because I have this set to increase variable instead of decrease variable. Not sure how I missed that, but I did. Column index, decrease by 1, increase. Okay, and now I think we do another test. We're going to have to refresh. So all that is incorrect. Let's run the test now. I have a feeling it's going to work now. Unless it doesn't, in which case it won't. Okay, it's looking good. Now, the game board will actually, the app will actually tell us if we succeeded by flashing and, making all kinds of colors all over the game board. Just like that. There we go. So it succeeded. We'll test it a couple more times here. This says that my time was 25 seconds, which is not bad. Let's test it one more time on easy. Okay, so this one's definitely taking longer. This is probably a good example of, and I don't know what exactly causes this, but depending on the layout of the numbers and stuff, where they are, it can actually make this method, this backtracking method, take a lot longer to find the solution. Whereas sometimes it can happen, within 20 seconds. I think I might fast forward this until the end and then come back to you once it's done that. And then I'll tell you the final time. Oh, it finished. Look at that. Okay. Well, okay, so it finished. The time was 2 minutes and 44 seconds. My guess is that's probably about the longest it will ever take on an easy level. And sometimes you saw it can take as little as like 20 or 30 seconds. So it's going to be inconsistent with the timing, but it's consistent in that it will always finish it. And so that's pretty cool. Thanks for watching, and I'll see you in the next video. I always forget what I say.